Basak Bektas. She's an associate scientist at the Iowa State University Institute for Transportation.
I think it's a good first AM presentation because I'm going to talk to you about the research that I would like to do and I haven't done yet. And I will kind of open it up for discussion, for ideas. So it's a total win for me, and I hope you will also enjoy it. So this is for, as I said, a newer project I'm doing with Wisconsin DOT. It's to develop a data-driven, cost-effective life cycle plan for bridge decks in Wisconsin. I'll go through the outline for you first. I'll first give brief information about the project. I will go through the initial project tasks and where we are right now. And then I will talk about the data I am planning to use for the project. Then I have some figures to go over the life cycle with you and how we are approaching and what we will do to get those parameters in the study. Overall analysis approach, and then hopefully we'll have a good discussion and I will take your notes. As I said, this project is for Wisconsin DOT, sponsored by Wisconsin Highway Research Program. It's a 2-year project. We started in October. November is a better starting point, and it ends in September 2019. And the main objective of the project is to come up with a cost-effective life cycle treatment plan for Wisconsin bridge deck preservation. There have been similar studies before. And there have been a national study in 2009, NCHRP study that looked at when and how agencies are doing these treatments. That particular study is a research we will cite, but it focused on a states survey basically, and asking states how long do they think these treatments last. What we're trying to do here is looking at data to see how these treatments performed for Wisconsin and how they should incorporate that to their decision making. Right now what we're working on is coming up a list of strategies through reviewing current practice. So we basically went through websites and started asking questions to other agencies on their experience. One thing that Wisconsin DOT would really like to see is, are there any newer treatments, overlays, materials that agencies are trying? We would like to also document that within this task. And also the experience, but another thing is for the success of these treatments, as you more closely know, is implementation is a big issue. So we're also trying to gather information regarding the experience of successful implementation and any things in construction implementation that agencies should be aware of. Again, the focus is trying to come up with data-driven estimates for performance and also the optimal timing. How soon after construction should you consider a particular treatment? How frequent should those treatments be? And how does the ISER usage and track traffic come into play? Do they come into play? There is also interest, this has been also brought up in our kickoff meeting. Wisconsin, if I can, would like me to, and our team to look at data from other state DOTs. So we are focusing on the Midwest Bridge Preservation Partnership states because we're at least thinking the behavior will be similar. Since it's a 2-year project, I will not have the chance to look at all the states' data, even if I had the chance. But if you're one of those states, and if I didn't have a chance to talk to you yet about it, I will go through kind of the data resources we will look at. basically, we would do the same data analysis for your state data. That would give you an idea on how particular treatments kind of lasted on your system. So this is kind of to come up with a range for Midwest. I think it's also, it's a partnership. It is a big focus in these groups, preservation groups. So I think it's also providing value from this research to the Midwest region. And then once we have kind of the data-driven estimates for the components of the life cycle plan, then of course we'll apply engineering economic principles to come up with a life cycle plan. The literature review is mostly done. That task is completed. We did an initial report for that in February. And now we're trying to wrap up the tasks B and C you see here. So there are still a few states that I need to talk to because some of these policies are already in place but not always written and presented in a website. They may be internal documents. There is a way agencies are already making these decisions based on experience. So this is kind of what we're trying to gather here and document. We're hoping to finish tasks B and C by mid-May. Some initial findings, these are again from studies that are probably that have been available and probably very familiar to you all. Sealers and overlays, these are cyclical preservation activities. For sealers, 3 to 5 years is a frequency typically advised or practiced by the agencies. And for overlays, it's typically 10 to 15 years. And the guidelines and how agencies apply them, their decision trees, if they have, it varies by agency. Some common criteria used for selection are type of overlay. For the type of the overlay are traffic, expected life, and the condition or level of deterioration at the time of application. For sealants, weather conditions and level of coloride are essential factors for deciding the sealant type. So initially, when I put the proposal together, in the RFP, the focus was on basically just sealers and thin polymer overlays. Then we had, and Wisconsin DOT is pretty organized. Before the research started, I think this was late summer, we had a meeting, online call, where they said, would you also look at these other overlays on our system? And it made sense, and it was a question I had for them, because if we are doing a life cycle plan, all related treatments should be accounted for. So basically we will be looking at all the sealers and polymer, all the overlays that they have used on their system. The focus is on state bridges. We're not looking at the local system for this project. And they already have a bridge preservation policy guide. I'll show you a slide on how that looks right now. So the idea is the findings from this research would go into updating their current policy guide and also go into their decision-making tools, change the parameters, adjust the parameters there. For condition, we will be looking at both MBI components and ash to element condition data. So this is the element side is the tricky side where I'll briefly talk to you about, and you are familiar with this. In 2011, a change happened. So we have project history that is before the new elements, and we have, again, history after the elements. We also know the migration issues between the two systems. It's not a complete match because varying surfaces are now taken out of the original commonly recognized elements. So, so far, I am not entirely clear how that we will kind of structure that part of the analysis, but that is something we will need to address. So this is kind of the current policy that the agency has. As you see, deck sealing and thin polymer overlays are defined as cyclical activities. Crack sealing is, deck sealing is advised for every 4 to 5 years, and thin polymer overlays are advised for every 10 years. And then you have, for condition-based treatments, asphalt overlays with membrane and polymer-modified asphalt overlays for, again, 12 to 15 or 6 to 12 year frequency. And then finally, you have the rigid concrete overlays and structural reinforced concrete overlays defined as condition-based. What we're hoping to find from data is what should that condition trigger be, what should that frequency be, and how soon, again, after construction or after another treatment, should these treatments be applied. So I'll briefly talk about kind of the data and organizational structure in the agency. On the right side, you're seeing the regions that Wisconsin. They also have a central system called Highway Structures Information System. Their project history and also most bridge data is kept in the system, which I can access and query. It's a web-based application. But there are also regional databases for the data that I would like to use. So 8 regions and 9 offices, as you see. Madison has 2 in Southwest. So HSIS has most central project information, but the sealants and some other overlays are also kept by the districts, by the regions. We are almost done with gathering those that information. I will talk about the coverage and completeness of that information. So condition data, the MBI site is easy. It's already downloaded and processed. But also element data, again, we're using the centrally collected data from the system, so it's also available to us. Another data source that I would like to use, and this has been brought up by the agency, is the ICER usage data. They have a database of automatic vehicle locator records for 7 seasons, and I will get an update for 2017. So far I got this part of the data. This basically gives us a total amount of the ICER material by segment and season. So again, there will be assumptions that will need to be made as it relates to how, because we will geospatially integrate this data, but how much of that, the ICER on the segment is really going on the bridge deck. This is part of the treatment history data we have gathered so far. So for the, there are some incompletes, as you see, and you also see a range with the year availability. So just looking at this, we can see, again, we may need to cluster this data as we are looking at it. Because when you're looking at performance of treatments, you're basically saying, this is what happens to your deck if you don't do something, and this is what happens when you do something. So the samples that you are looking at should be representative. So again, with the availability and coverage of treatments, we will need to exclude parts of the data, especially from the regions. I don't think that any of the data will be inaccessible. The 2 ones that have not been submitted yet in the bottom is that the person in charge has been on leave and should be coming back soon. Honestly, I was impressed with the data that I got, because I know Documentation is really not our forte as engineers. It's something we struggle with. I was glad to see that there is a good amount of data that I can work with. Also, this is just the regional data that I'm talking about here in terms of coverage and completeness. There's also project history for most overlays that comes from the DOT. So these are the current elements, new elements that the agency has. As you can imagine, we will be looking at both deck slab elements and also the varying surfaces and how we see trends since 2011 regarding these elements. This is just very initial look starting, when we started looking at the data, we started doing some charts to see, anomalies, is there anything that pulls our attention? This is just the inspection data for AC overlays with membrane. As you see, these are just the inspections for a particular year. It doesn't give a inventory picture because not every year you're inspecting your whole inventory. So as the inspections started in 2011, so we see kind of increasing number of inspections, and then we see like in 2016, 14, in the even years, there is more concentration of those types of structures basically being inspected. Of course, what we are more interested in is to see the shifts, the changes. This is just giving us the percentage in condition states for a particular year for that element. So one tool I previously developed and I like using in this type of research, which is very helpful, is this one, which is not giving you much detail, so I will try to walk you through it. So on the left-hand side, on the left column, you're seeing all the bridge IDs. So with this tool, basically, I can pull the MBI data for all available years for an agency. On the top, you are seeing years. So it goes back to, I think 80s we pulled it to track any available inspection from any MBI file. So basically, for each year and for each structure, we can pull the assigned MBI rating. So in the end, what you have is like a time series of MBI condition ratings. So you can see, hopefully, on the top one, you see from a condition rating of 5 in deck, you go to a 9. So you know something happened there. Sometimes you have big gaps. So you have these issues. But from this first table, then we progress into this one, where for each structure, we pull the MBI rating, the first year and last year for that particular rating, how many years that structure stayed in that value, and then what is the next value. And we are adding the previous value to this, but it's easy to gather actually through this. Because if you look at there for the first maybe 4, we are looking at the same structure. How long it was in 7, how long it was in 6, how long it was in 5, how long it was in 4, and so on. So the idea is then marry that condition data, the de-icer usage data, and the track traffic, and see how it affects the overall life cycle. What type we're trying to see patterns and combination of treatments and how that played into overall performance. I'm a poor drawer, but let's indulge me in this little figure here. So it's like a condition versus time simple graph, just to give a picture of how the components for the life cycle are. So, of course, with MBI, we wouldn't have this because it's not a continuous scale. You have a discrete scale. You would have straight lines and then improvements in between. So here you see, as deterioration happens, you try to do treatments to improve the condition. in this particular example, all treatments are assumed to increase condition. One decision to make is how soon, when you have a condition trigger, should you apply a particular treatment. This initial timing, it may be, again, a condition trigger, or it may be a policy related to age. So that's one component, the initial timing. And then what should you apply for which condition or which age? So that's your second level of decision. And then these treatments, how long do they last on your system? How different is it when it's a heavy truck corridor versus others? And if significant, things such as truck usage and the ICER use, the truck traffic and the ICER usage, are these significant enough for you to incorporate into your decision making? So one thing I again put in the proposal was like the fact that this is, the seasonal snowfall for Wisconsin for an older year. It is different when you look at the whole state. So I don't, for example, foresee to develop models for every single color that we see in the map, but I want to look at it. Will it be significant in performance? So that's one thing we're trying to have. And in the initial proposal, I had entertained some other additional parameters, but I'm so far focusing on the ICER usage and truck traffic based on experience for earlier deterioration modeling. Again, also including these external factors and looking at a combination of deck treatments, because you may have sealant overlay maybe not for a while. So what are the patterns in the data, and how that past experience should be brought into future decision making? And again, ideal timing for each bridge deck treatment or treatment combination with respect to condition and age, and coming up with service life estimates of these treatments. If you are a Midwest state who is interested in us working also on your data and coming up with these data-driven estimates, this is kind of what I'm working with in Wisconsin, the MBI condition data, which is available to everybody, so that's not an issue. DEX slab condition, this is the element condition history. Wearing surface condition, this is from the new ASHTO elements. Ideally, if you had separate elements, that would make life easier, but it's not a deal breaker. And traffic also, again, from the system, especially since I'm focusing mostly on truck data, and we have some missing fields in the MBI data, that would be useful if you had that information. The ICER usage I would like to have. I know all agencies will not have it, so that's again not an issue. But ideally, treatment history. So you may not have history on sealants, but maybe you have a good coverage of your overlays. So again, that would be useful, and I could work with that data. So once we have all of these data-driven estimates for Wisconsin, we will be putting them together with engineering economics and coming up with a life cycle plan. I just want to briefly discuss complexity here. As researchers, we like data, we like models, but my philosophy on network level decision trees or decision making is that it should be simple but sufficient, with enough sufficient details. So I'm not trying to come up with 10 models for truck traffic levels. I just want to look at the variability in the data and whether it really makes sense to do a separate decision tree, for example, or a life cycle plan for particular the ICER usage or truck traffic. Again, that's my contact information. If you would like to shoot me an email for this, I would appreciate it.
Are you taking into account any other different materials like rebar type, stainless steel, galvanized, or some of the
Yeah, so when I said
internals?
deck condition and deck properties, so we will look at also structural components of a particular deck and how that could play into. So one thing I don't want to claim in the beginning of a study like this is that if you have a very small sample size of particular parameters or variables in the data set, it's difficult to come up with, conclusions or generalizations. But those are things that we definitely will consider.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.